Good evening, team. Welcome back. I'm Corey, and we're about to get started on day 13 of Advent of Code in Rust, trying to get back in the groove of things, and after solving day 12, feeling pretty good. If you missed any of my previous solutions, check out the playlist up top for all my videos, and don't forget to like and subscribe for more. Let's get started. Okay, let's jump right into day 13. Day 13, Distress Signal. You climb the hill and try contacting the elves. However, instead you receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, your puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by blank lines. You need to identify how many pairs of packets are in the right order. For example, there's these pairs. Packet data consists of lists and integers. Each list starts with this, ends with this, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. Then, when comparing two values, the first value is called left and the second value is called right. Then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next pair. Okay. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, then the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. So the shorter one first. If the lists are of the same length and no comparison makes a decision about the order, continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. For example, if comparing 0, 0, 0, and 2, convert the right value to 2, a list containing 2, and the result is then found by instead comparing the list 0, 0, 0, and 2. Using these rules, you can determine which of the pairs in the example are in the right order. You compare this array versus this array. We compare them until we get to 3. 3 is smaller, so they're in the right order. We compare this one with this. 1 versus 1, 1 and 1, and then we compare 2 and 3. We make 4 an array. We compare 2 versus 4. The left side is smaller, so the inputs are in the right order. But then if both values are lists, then the second value. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. So isn't this one saying that... Okay, so we just have to hit the first one. We don't keep going down the list. So shorter list isn't always better. It's about the elements first. Mixed types convert this to a 9, 9, 8, 7. Right side is smaller, so inputs are not in the right order. Okay, yep. Right side ran out of items, so inputs are not. Okay, so rounding out of items just means that they were even until then. Okay, so I need to be able to compare two packets. Okay. So one thing that we're gonna need to do is we're gonna need to parse these. And I don't really know the best way to parse this. Like, this looks like right JSON. So, like, we could build something that could actually parse JSON relatively correctly, or we could just pull out a JSON parsing tool, and we might just pull out a JSON parser and parse this as JSON, and then interpret it from there. Because I think that's going to be the easiest. And that's not going to be trivial, but I think that'll be easier than anything else here. Okay, yep, let's get started there. So we are in our thing. Let's do cargo new 13. And this is distress signal. We're going to make a library. Its name is distress signal. Okay. Here's our test, and okay. Let's remove this, and let's do part 1, example input. Let input equal include string of example input. This is the same as we've always done. Let the answer equals part 1 on input. And what is our answer going to be? We're going to say how many are in the right order. What is the sum of the indices of those pairs? Okay. But still, the sum of them is 13. Okay, cool. Let's see, can I just generate this method? No, thought maybe I could just generate it. Public function, part 1, takes an input, which is some string, and we get a usize out of that. Okay, the body of it's just a to-do block, and we can probably, oh, no, I missed a step. That's why we can't run the tests. We have to actually add it to our cargo workspace here. Distress signal. Yes, I know. And now we can run our test. There we go. This needs to be answer. And then we actually need to include our example input here. New file, example input. Okay. Okay, so now we have our things here. And let's include string. What's going on here? Yeah, is it just that you don't realize the file exists yet? That's fine. I forgive you, but I think it exists. Not yet implemented. Awesome. Okay. So now we just need to actually start parsing this. So, I guess I want to do a struct for a packet. And it's gonna have either a list or an item. And I guess actually it says that a packet is always gonna be it's gonna have items, so it's gonna be a vec of list or number or integer. Where we have an enum, list or integer. I'm not actually sure if I like this. Where list is a vec of list or integer, or integer is a usize. That's actually not awful. And so then obviously we're just gonna try to parse packets. So then like, yeah, let's do parse packet first. So let's make an impl for, actually no, let's go and go the other way. Let's do enum packet pair. Left is a packet, and the right is also a packet. And then let's impl on packet pair. Function parse takes an input string and returns a self. And then so this is just going to be one of these. So let's do let split equals input dot split on a new line. We're gonna, oh, actually, so let's just do lines. Easier way to do that. Lines, and then on let's just do that. We're gonna make this mutable so that we can pull things off of this iterator. We do let the left equals split dot next dot unwrap, and then we do let left equals packet, and we parse left, and then we do let right equals the exact same thing, split dot next dot unwrap. We parse it, let right equals packet parse right, self left right. Okay, now I need to make this method. Okay, so we want to parse a packet, and I think this is where we're gonna pull in a dependency here. So for the first time, or not the first time, I don't think, but cargo add Saturday JSON so that we can pull in so we can get this JSON value. Because what we're gonna want to do here is I'm gonna parse the let JSON equals Saturday JSON from string, and our string here is gonna be input. We're just gonna unwrap it. We're gonna say we know it's gonna be something that we know how to understand. And I don't know why, well, I can just do this. I can tell you that it's gonna be a Saturday JSON value because I just wanna make it a value. Okay. Okay, so then we have the JSON, and then we want to go and do JSON dot okay, JSON dot as, because I know this is going to be an array. We're going to unwrap it, or actually expect, so I know what's happening here. The top level packet is always supposed to be an array. Okay, so as array, unwrap, this now has the type of a vec of values. Okay. Into iter.map, list or integer parse. From value. How about that? From value. From JSON? From JSON. I like from JSON. Oh. That's much better. Okay. Impl list or integer, impl function from JSON, takes in some input, which is a reference to a value, and we return a self. Okay, so match input, fill the match arms. Okay, so the only one I actually care about is if it's a number. I get some number. Okay, so then I want to do x dot as a u64. Yep. So what if we just returned u64? What if everything was a u64 instead? Perfect. Okay, so from JSON, this one is gonna return a self : integer of a as u64. Expected u64 found an option of a u64. Expect actually I don't know why this is mad. Should always fit in a u64. Okay, so if it's a string or an object, we're just gonna panic. We're gonna panic unsupported JSON. If it's an array, then we do array dot map self : list of mapping dot collect. Okay, so then this though is self from JSON. This is where we recurse into iter Perfect. Okay, so now this JSON though, just doesn't return the right thing. Found struct, I found a map. Okay, so then let items equal collect self items into iter. What don't you like about this here? Call iter directly. Oh, because it's an array. Okay. Or is it just gonna be a slice then, I guess? No, it's a vec. Huh, I guess just because it doesn't matter. Oh, because this is gonna take a reference of it, so I actually don't need it that way. Awesome. Okay. Um, Same thing here. Call iter directly. Cool. Cool, cool, cool. Okay. Let parsed equal okay. Let's do let packet pairs equals input dot split on a new line dot map packet pair parse dot collect into a vec debug a reference to packet pairs. Then this just is a to do. This is actually probably going to return a U64 now because that's what my. Oh, actually no, it can be a U size because it's just about indexes. It doesn't matter at all. Oh, everything needs to be debug. Derive debug. They also are going to be clone and partial equal. Okay, and we can finally run our test. It's not gonna pass, but it should parse. Let's find out. That looks like some parsed out things. We got 1, 2, 3, 4, and then 5, 6, 7, 8, 9, compared to some with 6, 0, 8, 9. Yeah, that's that one. Perfect. That looks parsed out perfectly. So the thing we kind of cheated on here is doing this with the thing we kind of cheated on here was having JSON parse this. We could have parsed this ourselves, but I didn't really want to. Okay, so what I think we want to do now is we want to implement partial comparison for our enum, really, following these rules. So what we want to do is for our list or integer, we want to do impl partial order, that's what it's called, for list or integer. That's all we got. Awesome. Implement missing. Okay, so what we need to do is we need to be able to partial compare the things. So first I think we want to do a match on reference to self and other. Self and other. I don't think I need the references here. Because if self if both values are integers, okay, well, so let's do the easy ones first. So we could have a self, this one is self integer L self integer right. And then in this case though, it's easy. You just do L dot partial comp R and you just return the number there. If we have self as a list, L comma self as a list R, here we need to do something more complicated, to do loop and check indices. But if we have a integer over here, and we have a list over here, then we redo this, then we do self list. Um, so if we have list over here, okay, so I just take my integer out. So then I just do self. This is gonna be weird, but it's fine. A vec bang of self integer left. That whole thing, that partial compare with self colon list on the right side. Expected a reference. That's fine. I can make a reference. Okay. Wow. Mismatch type. Expected found. Expected found a reference. Can I just pull that out? Oh yeah, no, because these are references, because I have references here. That's fine. It's just gonna be a clone. Not efficient, but like that's fine. Okay. But that's only one half of these. I need to do this in the opposite direction, where the left side is a list and the right side is an integer. So this thing is replaced with an R. The oh no, undo. Okay, I want to take this, copy you from there, put you at the beginning. This is where the dot partial compare is. We compare it to this thing. Not sure we need that. Let's remove it for the moment. Left. This wants to be an L. Now it probably wants to be cloned. This wants a borrow. Wow, that was all wrong. Okay. There we go. Cool. This though still wants some things there. That looks like I got all of those though. Okay, so then we do for I in um how do I want to go through and compare? Let max I equals L dot length dot min. Yeah. For I in 0 dot dot max I okay. Do let inner or like IL equal to L at I. Let IR equal to L at right, or nope, right at I. Wow. Okay. So this though is a list or integer. So then we do let result equals IL dot partial compare IR. So partial ordering. Are these just always ORed? I think I might just be wanting ORed, not partial ORed, because I'm never returning a sum. Like, I'm always returning a sum. Everything's comparable. Yeah, I think things are always comparable. Partial. Oh, that's where I'm doing a partial. Perfect. Partial. No more partials. Okay, awesome. Um, oh, there's way more things on this than I wanted there to be. Okay, let's go back to doing partial compare. That's just easier. Okay, sure. Reference it, reference it. Um, yeah, I can just forward it down. If you get something here, then just return none. We just can't compare. I don't think that's actually gonna happen though. Actually, do I just want to unwrap here? Yeah, I think I do because I don't expect that to happen. Okay, so if the result, if result, I guess I want to just do match on result. Fill match arms sounds like a great idea. So if it's equal, that's the case that I want to just continue in my loop. If it's if it's anything else, we want to return what it is. So then if it's X, we just return X, and we just stop looping. Return a sum. Yeah, there definitely is an ordering. It's that. And then I guess if we get to the end here, no, if we get to the end here, this is a sum. Standard. Compare. Standard. Compare. Ordering. Equal. Okay, so then I think then what we just want to do is we want to do packet pairs dot enumerate dot iter dot enumerate dot map yeah map to something. I don't actually know the order here. Dot sum. Filter map. Wait a sec, what am I doing this to? I want to find the index where they are, the indexes where they are that. So I guess I do want like a filter map kind of thing. Filter map dot sum. Okay, so this is the I, and this is the pair. Okay, so then this is something that's like, oops. If pair dot left is less than pair dot right, then we do sum I, else we do none. Partial order less than. Why can't I do that though? Can't apply less than for packet. An implementation of partial order might be missing for packet. Oh, okay. There is one missing for packet because I implemented it for the thing underneath, but I should be able to really easily do impl partial order for packet. Oh, actually, wait, can I just do this? Partial order? Because now it should just let me do this. Yeah. Wow. Okay, cool. Didn't work. Would have been too easy if that worked. Oh, we actually got an answer though. We got 9 instead of 13. So I think then what I want to do is let indexes equal this, collect it to a vec, and then we debug out the indexes, and then we do indexes dot iter dot sum. Okay, and now we see that I think it's 0, 1, 3, and 5. Okay, so 0. Oh, wait, is it pair? Oh, are they numbered like that? Um, the pairs are 1, 2, 4. Oh, wow. Yeah, 1, 2, 4, 6. Okay, perfect. That's easy. So it's just that the this wants to be I plus 1. Yay! Okay, I don't really need this debug. And then I really don't need to do this collecting. We'll use, nope, it doesn't want to fix it for me. Boop, boop, the sum, and all of that goes away. Perfect. Okay, let's test it with my input. My input, let's grab it. New file, my input. Ah, part 1, my input. 5981. 5981. Oh, not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. Okay, so 5981 was my guess. And 5981. Okay, so that is the answer that this thing spat out at me. So now I get to play the game of figuring out which ones aren't gonna match. Oh, I think I didn't do, I know what I didn't do. I didn't implement a condition here. I didn't implement the condition of what happens when we're done. So if we're done, I said they're equal, but that's not true. So if the L dot length is less than R dot length, so if left ran out first, if both values are lists, if the left list run out of items first, the inputs are in the right order. Yeah, so if left is less, then we do standard comp ordering less. Else, let's just do equals first. Else if L dot length is less than R dot length. There we go. And then this then is just an else with, whoa, come back. So I've got some syntax wrong somewhere. Ah, that's what's happening. There we go. Okay. Move condition to guard match. Oh, whoa. Wait a sec. What? This whole thing. Whoa. Wait. No. Undo. This whole thing just became move condition to guard match. Okay, left. If they're the same. Oh, wow. Lists that are the same length. No, but I don't want that. Because I need to do this first. This is more important. We only do this if this isn't the case. So that doesn't work. Cool. So I think I found one where this isn't applicable. Clippy comparison chain. Consider rewriting the if chain to use comparison and match. Oh, okay. Well, that I can do. That I could do. Match L dot partial compare, or is even just compare. Length dot compare to r dot length. That's totally fair. Like this one, that's pretty fair. Oh wait, is that all I want? Oh, oh. So much better. I was just re-implementing this whole thing. Just do the comparison on the lengths as long as we get all the way through. Okay. Does that change this one? It shouldn't. Perfect. Does it change this one? 5390. Let's try that now. There we go. Okay, part 1. Let's make a commit. Day 13, part 1. Feels good to get a part 1 done in a day. I'm going to try to keep these videos to an hour here, so let's see what we can do in the next 20 minutes for part 2. Now part 2, now you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. Using the same rules as before, organize all packets, the ones in your list of received packets as well as the 2 divider packets, into the correct order. For the example above, the result of putting the packets in the correct order is this. Afterward, locate the divider packets. To define the decoder key for this distress signal, you need to determine the indexes of the 2 divider packets and multiply them together. The first packet is at index 1. The second packet is at index 2. In this example, the divider packets are 10 and 14, so the decoder is at that. So you multiply them together. Okay. Organize all the packets into the correct order. What is the decoder key for the distressor signal? So the first thing I want to do is, like, can I just sort these? I think they're probably just gonna be sortable. So let's just do that for part 2. Okay, so there's a part 2. Just give it a to do. And let's take this, pop it down here, part 2, and the answer is 140. Okay. So the first thing that we want to do is we just want to get to packets this time. We don't really care about anything else. So let's do input.g sub. Can I just like substitute or replace? Replace all matches from, yep, replace from new line with the new line. Does that mutate this? Mutable. Replaces them. Oh, returning a new one. Okay, so let input equal that. This doesn't need to be mutable. Okay, and then this is actually just going to be packet.parse. This is then packets. Let's make this mutable though, so that I can just do packets.sort. And then we debug out the reference to packets. But packets here, okay, so it has to be comparable, not just partial comparable. But the thing here is, I think that, oh wait, no, ord. Oh. Oh, I'm also missing up compare and ord, but that's okay. Um, the partial order. Does it then also order, does it like compare? Convert to manual impl compare, sure. Okay, well, it doesn't know what compare is. Okay, but what does it tell me about this? Because this was telling me that, oh, it just needs to be order, and I have it be partial order. Okay, again, I kind of knew that. can I just tell it to do this? Um, Packets can't be equaled. Oh, okay. Sure they can. Um, mm, can you just be equaled? Order is not satisfied. Um, import ord or list or integer. Uh, implement default members? No. Oh, those are the defaults. Oh, cool. That makes sense. Self dot partial compare dot other dot unwrap. What I really should do here is just have this beak do it the other direction and then just wrap it in a sum at the end, but that's okay. Okay, did this order in a seemingly... Oh, we... trailing characters. Uh, line 10 is where we blew up. If I just trim it? Not really sure. Trailing characters. Okay, so what are we trying to parse here? It's probably something... Oh, no, definitely not that. I almost just debugged out the string input, which would not have been helpful. Um, the input equals... Oh. Split on a single new line. There we go. Okay. Um, arrow wall parsing of value. Yeah, so then trim there. Wait, what do you... Replace creates a new string and copies. Okay, okay, but there's this other trim up here that I don't think I need. This one. Okay. Okay, we got to not yet implemented. Nines at the end, then 8, 7, then some sevens, some other sevens. Okay, that looks right to me. Okay, so then we want to do let a first divider equals it just equals this. Packet parse this. Let second divider equals packet parse this. I could have just replaced it, but that's okay. I also could definitely construct this manually, but also I already wrote the parser thing, so packets dot push first divider packets dot push second divider. Not sure why that didn't autocomplete for me. Let first index packets dot iter. So I think I do iter dot position. Position of a predicate. Is there just like a find then? Find. A search for an element iterator that satisfies the predicate takes a closure that returns true or false. It applies this closure to the additional iterator, and if any of them return true, find returns some element. No, I want position. I feel like there's got to be an easier way to do that, but that's okay. What are we trying to do? We're trying to compare a is not implemented for packet. Can't compare packet with packet, so that should do the trick. Um, Whoa. Uh, Packet doesn't implement copy. I feel like there's an easier way to do this. Packets dot what do we have? I don't want an as. I don't want a binary search. I just want to get the position. Yeah, maybe I do really want to use an iter method. Um, Partition, peekable. Yeah, I really just want position. Okay, that's fine. I'll figure out how to make position work. Um, Move occurs because first divider has type packet, which does not implement copy. Yeah, that's fine. I don't care about that too much. Can't compare. Borrow occurs due to use enclosure, but what if we don't? What if we do it the other way? Is that gonna help? First divider equals x. Value borrowed here after move. Oh. It's mad about these. First index times second index. Plus one. Plus one. Woohoo! Let's get rid of the debug that I've got up here. No more. And part two's looking good. My input. Part two, my input. And we get an answer of 19,261. 19,261. And there we go. Day 13, part 2. Let's write this in and commit that up. 19,261. We can run all the tests and... Oh, we don't get them all passing. 59, 5390. I didn't ever replace this one. There we go, all four. Day 13, part 2. Feels good to get one done all in one session. Let's push these up. Okay, and that is gonna wrap up day 13 of Advent of Code in Rust. I hope you're enjoying these videos. I'm really enjoying making them. And like and subscribe for more, and day 14 will be coming at you real soon. Thanks. Bye.